Welcome to General Chemistry Mini Lecture Series, Lecture 43, Formal Charge and Resonance Structures. During chemical reaction and bond formation, atoms may end up with more or fewer electrons than its valence electrons. Then the valence electrons they brought in order to fulfill octets, and that results in each atom having a formal charge. Formal charge is used to distinguish between competing Lewis structures or resonance structures. The formal charge can be calculated by subtracting the number of non-bonding electrons and 1/2 of the number of the bonding electrons from the number of valence electrons. Or I prefer to use this equation, Fc, formal charge, equals the number of valence electrons subtracted by non-bonding electrons subtracted by 1/2 of bonding electrons. Let's find the formal charge on each atom in a water molecule. First, we need to draw the Lewis structure for water molecules, 2 single bonds and 2 lone pairs. Now let's use this key equation to find out the formal charge for each atom. First, for the oxygen atom, because it's a 6A element, therefore 6 valence electrons, and the number of non-bonding electrons, 2 pairs, 2 lone pairs, that's 4 non-bonding electrons. And then the number of bonding electrons, 1, 2, 2 single bonds. The total number of bonding electrons should be 4 times 1/2, that's 2. Then 6 minus 4 minus 2 equals 0. The number of electrons for those 2 hydrogen atoms, they are identical. Okay, so they are the same. Each just is connected to a single bond. So therefore, valence electron, 1 for hydrogen, subtract by non-bonding electrons, no, there are no lone pairs, and then subtract by 1/2 of the bonding electrons. Each single bond contains 2 electrons, so therefore that's 1. 1 minus 1 equals 0. The overall formal charge for water molecule is 0, and that equals the charge of this neutral molecule. Let's work on another example, phosphoric acid. First, we draw the Lewis structure for the molecule. Now we use this key equation to find out the formal charge on each individual atom. First, the central atom, phosphorus. Phosphorus is located in group 5A, so therefore, number of valence electrons should be 5. There is no lone pair, therefore, the number of non-bonding electrons is 0. And then there are 4 single bonds, that is equivalent to 8 shared electrons, bonding electrons. So therefore, 1/2 times 8, that's 4. 5 minus 4 equals +1. The formal charge for phosphorus atom is +1. All 3 hydrogen atoms, they have the same formal charge, and that is 0, according to this equation. We have 2 different types of oxygen. The first one is the oxygen atom at the top. We are talking about this one right here. Number of valence electrons for oxygen, that's 6. Non-bonding electrons, 3 lone pairs, that's 6 again. Then 1 single bond, that's 2 bonding electrons, Therefore, that should be 6 minus 6 minus 1 equals -1. The other 3 oxygen atoms, they have the same formal charges. Number of valence electrons, again, that's 6. The number of lone pair electrons becomes 4 for each of those. And then the number of bonding electrons, that's 4 as well. 2 single bonds, 4. So therefore, the 6 minus 4 minus 2 equals 0. Now let's look at the overall formal charge for phosphoric acid molecule. That should be +1 plus -1 equals 0. Let's work on nitrite ion, NO2 minus. First, draw the Lewis structure. Make sure you label that as an ion. And now let's find out the formal charge for nitrogen. Nitrogen is in group 5A. Therefore, number of valence electrons, that should be 5, subtracted by 2 non-bonding electrons, and then subtracted by 6 bonding electrons. Why 6? Each single bond contains 2 electrons, and each double bond contains 4 electrons. That's a total of 6. So therefore, this is a 5 minus 2 minus 3 equals 0. The formal charge for nitrogen is 0. The formal charge for the left oxygen, number of valence electron, 6. 2 lone pairs, 4 non-bonding electrons, 1 double bond, 4 bonding electrons. Therefore, the formal charge for the left oxygen atom is 0. Now let's take a look at the oxygen on the right. 6 valence electrons and 6 non-bonding electrons, 2 bonding electrons. -1 is the formal charge. The overall formal charge for the ion is -1. That equals the charge of nitrite ion. Resonance is a result of a delocalized electron pair bonding. Let's take ozone molecule as an example. This is one of the Lewis structures of O3 molecule, and this is the other Lewis structure for O3 molecule. You may say they are the same. Yes, but when this happens, actually resonance occurs. Neither structure is actually correct, but a hybrid of the two with delocalized electrons can correctly represent the electron locations in ozone molecule. The electrons we see here, they are all localized electrons. For example, those 3 lone pairs, they are localized electrons surrounding this oxygen atom. And those 2 bonding electrons, they are localized electrons between these 2 oxygen. So therefore, in this structure, all electrons are localized. However, if we move these lone pair electrons to here, as a result of that, we have this structure. But all of those electrons in this structure are still localized electrons. Now let's concentrate on this lone pair electrons. Instead of being localized electrons only surrounding this atom or surrounding this atom, now this pair of electrons are shared by 3 oxygen atoms. You see right here? So we call this a resonance hybrid or resonance structure. Now we go over rules for formal charge and resonance structures. Number 1, the sum of all formal charges in a neutral molecule must be 0 because neutral molecules carry no charges. The sum of all formal charges in an ion must equal the charge of the ion. Smaller formal charge, and we are talking about absolute values. It means -1 is smaller than -2. So smaller formal charge is better than larger ones. A negative formal charge must reside on more electronegative atoms. Avoid like charges, like positive next to positive or negative next to negative on adjacent atoms. Resonance structures must have the same connectivity, only electron positions can change. Also, resonance structures must have the same number of electrons. Those are the rules for formal charges and resonance structures. Let's take a look, which is the stable Lewis structure for carbon dioxide molecule. We need to draw the Lewis structure for CO2 molecule. Two structures are shown right here. We'll use the formal charge equation. Work on structure 1. The formal charge for carbon is +2. Formal charge for each oxygen atom, that's -1. Overall, formal charge for the molecule is +2. For carbon, there are 2 oxygen atoms, and for each oxygen atom is -1, so therefore that's 0. Now, for structure 2, the formal charge for carbon atom, that's 0. Formal charge for each of the oxygen here is 0. Therefore, the overall charge is 0. The carbon atom in structure A, it only has 4 valence electrons, and that does not meet the octet rule. Therefore, from this perspective, structure A is not a favorite structure at all. But in addition to that, the formal charges for structure B, they all are the smallest one possible, which is 0. And in structure A, the formal charge for carbon is +2, for each of the oxygen is -1. Therefore, structure B is much better than structure A. Now let's determine the best resonance structure for isocyanate ion. We have 3 Lewis structures. Let's apply this formal charge equation to find out the formal charges on each of those atoms in all 3 structures. Let's start with structure A. Formal charge for nitrogen, -2. Formal charge for carbon, 0. Formal charge for oxygen, +1. The overall, -2 plus 1 is -1. That equals the charge of the ion. We will do the same for structure B and C. Now, using those formal charge values, let's determine which one is the best resonance structure. We'll start with structure A first. Structure A has the largest formal charge on one of the atoms, actually on nitrogen atom. Please note, when we talk about the formal charge values, in this case, we only pay attention to the absolute value. So therefore, the largest formal charge in structure A, that's 2. And in other structures, we don't see 2 anymore. So therefore, structure A is the least favorite resonance structure. Structure C has a negative formal charge on oxygen atom, and the oxygen atom is the most electronegative element among all of the 3 elements in this ion. Therefore, structure C is the most favorite resonance structure. That's it for lecture 43. I will see you guys in lecture 44, bond energy and bond length.